Okay, I want to talk about similar shapes. So, obviously one's bigger than the other. And basically, I want to look at how area, and if it's a 3D shape, volume changes between the two shapes, okay? So first, can you spot the mistake? Because this is something which close to nobody ever gets right, but it's so nice and straightforward. It's okay, so let's have a look at this, okay? So you got like this rectangle, or it doesn't matter what shape it is, yeah? But so you know that this side is 5 and you know this side is 2. So 10, yeah? So, I mean, it's pretty quick to kind of realize that, oh, the scale factor is 2, right? Because each side is being multiplied by 2. So now, imagine you're told that the area of this is 20. Well, actually, I shouldn't. Okay. What would the area of this one be? So we know the scale factor is 2 between them. The area of this one is 20. What is the area of this one? Now, here's what most people say, 40. Because they're like, if that's 20 and I know the scale factor's 2, then the area of this 40. That is wrong, okay? Because scale factor only affects length. It does not affect area or volume. And if you get this, these questions become very simple, okay? So for example, let me just kind of like rub this out. Let me actually kind of explain to you what this means, all right? So for example, imagine, I shouldn't have rubbed that out, to be honest. So, imagine the area of this is 20, okay? So imagine that side is 4. Well, can you see, obviously, scale factor affects length. So if I know that this has been multiplied by 2, I also know that this has been multiplied by 2. So this will be 8. So the area here would be 80. It's actually times by 2 twice. Okay? Now let me explain this in a better way. So one way you can think about it, rather than think about this 8 and 10, can you see if this is 4 and 5, can you think of this as 4 times 2 and this is 5 times 2, right? So if you kind of want to look at what the area of this is, you could think of it as 4 times 2 times 5 times 2. I know this sounds stupid right now what I'm doing, okay? And I can rewrite that as 4 times 5, which is really what the original area here is, times the scale factor times the scale factor. So what this actually becomes is the original area times scale factor squared. So here's how it is, okay? Shapes. Length, area, volume, okay? Old to new, or big to small, that's what it should have been, okay? So this one will be times the scale factor. But if I want to times it by area, I actually would times it by scale factor squared. And if we look at volume, it's going to be scale factor cubed. And again, so let me kind of go through that. Trust me, just keep watching. It will make complete sense. Yeah. So let's have a look at a 3D shape as well. Yeah. So here's what we need to understand. So here's a 3D shape. So and I know that doesn't look bigger, but just imagine that's bigger, yeah? So imagine that's 2, imagine that's 3, and imagine that's 5, okay? Now imagine if the scale factor here is 3. So by the way, the volume here will be 2 times 3, which is 6 times that. So the volume here is 30. Now, imagine I told you that the scale factor is 3, okay? So by the way, the first thing, here's how you should figure out the volume. You do times scale factor, which is 3, and you want to cube it, okay? So you actually want to do times 3 cubed, so which is 27. So do 27, so times 30. The volume is going to be 810, but let's kind of understand why it's 810 as well. It's because if you think of this as 2 times 3, and I'm going to put the scale factor there, that would be 3 times 3 scale factors there, 5 times 3. Can you see when you think of the volume, you got your original 235, so you got 235, which is your original, then you're being times by times 3 times 3 times 3. That's why. So you can take your original volume and just times it by 3 cubed. That's why that works. Now, even if that is still you're feeling, huh? What the hell are you talking about? Don't worry. As we go through these questions, it will make a lot of sense. But my point being, okay, for all of these questions, you need to find, here's what you do, okay? One, you find scale factor. Second, use table above. Okay, so they're going to give you two shapes, yeah? You're going to get two shapes which are similar, one's bigger and smaller. What you need, and they might give you something like, oh, the area of this is. Now find what the area of this shape is. So what you're going to do every single time, you're going to first find the scale factor, and then you're going to use the table above to find it. And I'm telling you, the questions never change once you kind of get that. So let's have a look at something like this. We can look at all the different kind of like types of questions which come along with it. So imagine we've got that question, so you're given two kind of shapes. Let's get the other questions in there as well. Okay, and then there's part 2 here. Snipper. Okay. So remember, by the way, area is the same as surface area. It's a 2D shape, okay? Sorry, so here's the deal. So the first thing we want to do is find the scale factor. Now, can you see, because these are mathematically similar, all you're looking for is a side. So you know that the scale factor here is 2. Okay? Excellent stuff. So let's have a look at what we know about this shape. We know that, so like if we look at A and B here, yeah, if I just do that. Here's what we know. We know, if we read this, two shapes A and B are mathematically similar. This one has radius of 4, this one has radius of 8. That's how we immediately knew scale factors 2. Because we know that scale factor affects length. So we know between that it's been multiplied by 2. Here's what we do now. We know that the surface area here is 80. And this question is saying, find the surface area of B. So the area here, can you see, we're going to have to do times. So remember, if I want to go between the big and the small, I have to times by scale factor squared. So I would have to do 80 times my scale factor, which is 2 squared. That's how I'm going to find my thing. There's no other way of finding this thing. It's not like, this isn't a shape I know. It's sort of like a cone which has been cut off. So the answer to this is going to be 320. Does that make sense? Yeah? And now let's have a look at this. So you're told now that the volume here is 600. Okay, it's saying find the volume here. Well, now, first thing to understand, between here and here, if we were going between big and small, we would have to times by scale factor, which is 2, and we would cube it. So to go from the small to the big one, we're going to have to divide by 2 cubed. Okay, so this one's going to be 600 divided by 2 cubed, which is 8. So, okay, so 600. The answer to the volume was 75. Does that make sense? Yeah? Okay, let's rub a lot of this stuff out. And the more and as we go through these questions, it will start feeling easier and easier. Yeah, so one part of this, perfect. Okay, let me snip that. Okay, so let's have a look at this, right? These two are mathematically similar. It goes the height of cylinder B, yeah? It's double that, okay? So it's between there. So can you see, it's already told you to go between here and here on the length. It's 2, so we know right away the scale factor is 2. We always need to find that scale factor. And now it's saying that the total, so if we look at A, look at B here, so we know that the surface area here, so you can write A or SA equals. Surface area of that is 180. So it's saying what's the surface area here? Well, remember, to go from between here and here, you're going to have to do times the scale factor squared, because that's how the area works. Scale factor is 2, so really you just want to times this by 4. And it is what it is. 720, yeah. Okay? Simple as that. Literally as simple as that. Assuming it kind of makes sense, you know. I mean, like, I say like as simple as that. If it doesn't click, it doesn't click, and it's a, you know, it's a nightmare. But yeah, if it has clicked, you probably feel pretty good. Oh, this one looks frightening, right? And to be honest, it's not actually similar shapes question, so ignore that one. Let's have a look at this one. Okay, here's a good one. Okay, so let's have a little look at this. So this one, let's have a look. So we know surface area here. And this is the way I actually recommend you lay out for a lot of surface area volume. Okay, so let's kind of see what we know. We know the length of cylinders, that is 4, that's 6. So to find the scale factor here is, well, we do have to do 6 divided by 4, but the answer is 1.5. Okay, scale factor is 1.5, we always go do that. Now let's kind of fill in what we know here, okay? We know that the volume of cylinder A is 80. Okay, so we don't actually need anything about the surface area. So it's saying basically find the volume here. Well, can you see that's going to be, so to go between volume, surface area, cubed. So you're going to times it by 1.5 cubed. So this is 80 times 1.5 cubed. Let's find out what that is. Yeah, you get 270. And by the way, the numbers aren't always going to be nice, you know. But yeah, that's basically all it is. Simple as that. Now, there's a particular type of question I want to look at because it catches people. This is the one. This is the one. Yes, yes, this is good. Okay, so no drawings, no nothing like that. Looks absolutely miserable. Two geometrically shapes. So you've got X and Y. Okay. So here's X, here's Y. We don't need the shapes. Here's what we do know, okay? So let's kind of do our surface area equals our volume equals. So the surface area of this one is 450, and for this one it's 800. Now we know this one has 1350, and we've got to find the volume of this shape. Now, so we know right away that what we need to do between two volumes, between the smaller and bigger, is we need to times it by surface area cubed. But it may seem like surface area right away is not obvious, so like we can't find it, right? Because it says nothing about the lengths. Here's what we do know. Between these two things, we got surface area squared. So whatever the surface area is, it got squared here to get, you know, from 450 to 800. So if I just kind of call surface area like let me just call it, you know, like Z, okay? Can you see it be like Z squared? So think about it this way. You know that 450 got multiplied by the surface area squared to give you 800. So you make a little equation like that. Now let's find what Z is. So if we get Z equals 800 over 450, and now if we just square root it, so let's do that. We actually find the what's it called? The scale factor. Sorry, I'm just not a multitasker. And this is 4 over 3, or 1.33333. Well, now this is easy. Okay, so you can just do times 4 over 3, put it in a bracket cube, or you could have done it as times 1.333 cubed. Doesn't matter either way. So if I cube that, times that by 1350, the answer to this is 3200. Okay, so that's how you do that as well. And yeah, like, and let's just kind of play around with this a little bit more. See if there's, you can, well, there's another, let's see if I can find another question. I'm trying to find a specific type of question. Yeah, okay. Yeah, okay, let's do question 6. So bang on what I want, but I'll make a question if need be. Have I got everything I need there? Yeah, got everything. Okay, so let's have a look at this kind of question here. So let's see what we do know if I just kind of make like a P and a Q here. So it says, I know that the surface area here is 90 pi, and I know that the surface area here is 810 pi. Now that's the area, right? So I know that it got multiplied by surface area squared there. Okay, and it's saying that the length of the cylinder here is 4. It's saying what is the length of cylinder here? Well, can you see between there? I just need to times by a scale factor, which is because to go between a scale factor only affects length. So first I got to make like a little equation to try find out what the hell's going on. So I go z squared, and not what's going on, to find the scale factor. So if I divide by 90 pi, I get z squared equals 810 pi over 90 pi, which by the way you can cancel that, and that just becomes 9. So the scale factor is just 3, but you could use the calculator as well. Alright, so we're just going to times it by 3 basically. So the answer for this is 12. And similarly here, as soon as you know that, yeah, so we know that the volume of P is 100 pi, saying what's the new volume here, and give you an answer. So we know this is like scale factor cubed. Well, scale factor is 3, so we cube it, so we actually times it by 27. Times that by 27, you get 2,700 pi. That's your answer here, 2,700 pi. Pretty quick, I know, but like, you know. So now let's actually just look at just like the last variation. I couldn't find it anywhere. Okay, so imagine they told you this, all right? So okay, here's like a little teddy, terrible teddy, yeah, and here's a bigger teddy, which is essentially the same. Okay, but so the 3D shapes and stuff as well, yeah. So now, imagine if I told you this, okay? So I tell you that the surface, here's the deal, okay? So I tell you the surface area of this is 1,100, and I want you to find this. Here's what I do tell you about volume. I tell you this volume is 600, and I tell you that this volume is 1,400, okay? Now, let's think about how this would work. That's how you do this. Now, between here and here, to go from small surface area to big surface area, you'd have to times it by scale factor squared. So between here, we need to find the scale factor, and we need to actually divide by it squared. But unfortunately, we don't know what the scale factor is. How are we going to find that? Because we don't know the lengths. Okay, what happens between the smaller volume and the bigger volume? Well, this gets multiplied by scale factor cubed. So we can actually make an equation there because we know both those values. So we know that 600 times scale factor cubed equals 1,400. So we can divide by 600 here. Get 1,400 over 600, which can actually be simplified down to 7 over 3 if you want, but it's not important. Now, we have to take the cube root, okay? Because we're undoing this cube. So be careful to make sure put in that. You could have put 1,400 over 600 as well. So let's remember cube root. Hopefully you know how to do that. So our answer is this, you know, it's weirdish number, but it is what it is. It's just a number. So good. Okay, so we now know that the scale factor is 1.32 squared. So this means to find this, we're going to be doing the old one, 1100 divided by 1.326 squared. So if I just do that, yeah, so my surface area here is 62528. So that's how the surface area stuff works, guys. Hopefully that makes sense.